Hi everyone and welcome back. In this lecture we are going to learn about the benefit transfer approach. Imagine you need to justify the importance of a protected area to policymakers next month, but you don't have the time or the budget to run a full economic evaluation study. What do? You use benefit transfer. To be honest, there is no other solution under this scenario, so you're gonna use benefit transfer. Before we start, this lecture will be based on a book called Benefit Transfer of Environmental Resource Values. It is a notebook. It was written in 2050, but it has all the fundamentals. According to this book, and the reference is in the description of this video, the benefit transfer approach can be defined as the use of results from existing primary studies at one or more sites, usually called study sites, to predict welfare estimates or related information for other typically unstudied sites called policy sites. So in a way, it is an extrapolation. You are extrapolating the results from one situation to another similar situation. However, you must be careful when using it, and more importantly, you must understand that this approach is not a substitute for primary research and it won't provide an accurate result. The estimated result will be a rough estimate, or as they say in the United States, a ballpark figure. The need for benefit transfer studies is the result of an increase in demand for economic information, especially in cost-benefit analysis, where the value of environmental impacts became a legal requirement in many countries, including the requirement of including the value of non-market benefits and costs. In addition to this, we have that this approach is quicker and at low cost when compared to other valuation approaches. And despite not providing the most accurate estimates, the values estimated are in many cases enough from a policy perspective. When using benefit transfer approaches, it is important to follow some best practice guidelines. In this part of the lecture, I will follow the four-step framework proposed by the U.S. Environmental Protection Agency. The first step consists of defining the policy scenario and characteristics clearly. The goal in this step is to understand the decision context in detail, so you know exactly what you're valuing. So the things you have to do are describe the policy change, for example, creating like a marine protected area, improving water quality, or reducing emissions. You will have to identify the affected population, who benefits and who bears the cost, describe the geographic, ecological, and socioeconomic context of the site or the area you are interested in, and specify environmental endpoints, what is changing, species, recreation opportunities, ecosystem services, etc. Why this is important? Because if you don't clearly define your scenario, you risk applying study values that don't match your setting. The second step consists of searching for primary studies that could be used to conduct the transfer. In this step, it is necessary to identify studies that value similar ecosystem services under comparable ecological and social conditions. You will also need to assess the quality of the selected primary studies. To help you with this assignment, the agency provides some guidelines questions such as what appropriate valuation method is used, are the data recent and representative, was peer review or expert evaluation involved? This step is crucial since the credibility of your benefit transfer depends on how well your source studies match your target scenario policy site. The third step consists of applying the selected values in a systematic systematic and transparent way. If there is one thing that is consistent among all my lectures, the need for it to be transparent always. This is crucial. In the case of the benefit transfer, the more context information you provide, the more reliable potentially your study will be. The last step consists of reporting the results. You should present the results clearly, including assumptions, limitations, and potential errors. So you must explain your transfer method and how you chose the primary studies, provide confidence intervals or sensitive analysis if possible, discuss potential biases and uncertainties due to difference between sites or evaluation methods. Make results reproducible by documenting every step. This step is important because although I mentioned at the beginning that from a policy perspective accuracy is not that important, it is something that you should aim for. At the end of the day, you would like to have estimates that are reliable and robust. The benefit transfer approach has several methods. First is the unit value transfer method, sometimes called point estimate transfer. This is the simplest form of benefit transfer. You take a single value, like a willingness to pay per household or per visit from an existing study, then you scale it up to your policy site based on population or area. So, for example, if a study found that people willing to pay $50 per household for wetland protection, and your site has 10,000 households, you multiply to get like a rough total value. This method is fast and inexpensive, but it's also very approximate. Next, we have the adjusted unity value transfer method. Here we adjust the value to account for basic difference like income levels between populations. For instance, if households in your study area earn less than those in the original study, you'd adjust the willingness to pay downward using an economic elasticity factor. This makes results a bit more realistic, but is still a fairly rough approach. Then we have the function transfer method. Instead of just using like a single value, we transfer the valuation function, a model equation estimated in a primary study. That means if the original study modeled willingness to pay as a function of income, resource quality, or distance, you can plug in your own site's variables to estimate willingness to pay. Function transfer is a more data-intensive, but it lets us tailor values more accurately to our policy setting. Finally, we have the meta-analysis transfer method. This is the gold standard when there is enough research available. So here's what happens. We collect dozens, even like hundreds of valuation studies on the same type of ecosystem service. We extract data on the reported values and characteristics of each study. Things like ecosystem type, country, method used, and sample demographics. We build a regression model that explains how the value changes across contexts. Finally, we use that model to predict a value for your policy site based on its unique characteristics. This method is transparent, reproducible, and robust. It is widely used in large-scale assessments like national ecosystem service evaluations or cost-benefit analysis of major environmental policies. But as expected, it's also time-intensive. You need a rich database of studies and strong modeling skills. Now that we've gone over benefit transfer methods, let's look at a peer-reviewed case study that demonstrates how the meta-analysis for benefit transfer works in practice. We'll focus on a 2022 study published in Wetlands Ecology and Management that used meta-analysis to value ecosystem service from agricultural wetlands. This is a great example because it shows how researchers systematically review valuation literature, how they build a mental regression model, and how this improves the accuracy of benefit transfer. The study goal is to answer two main questions. What are the economic values of ecosystem services provided by agriculture wetlands globally? And can meta-analysis reduce the errors that often come with simple benefit transfer? Here we will focus on the first question. They started by conducting a global systematic review, searched hundreds of valuation studies published over several decades. They identified 668 relevant studies on wetlands and narrowed this down to 45 studies from 22 countries that had the right data for meta-analysis. So for each one of these 45 studies, they extracted the reported monetary value of wetland services, details about the wetland type, the service category, provision or regulating, geographic region, valuation methods used, and socioeconomic data like GDP per capita. With this data, they built a meta-regression model. Here's the idea. The dependent variable was the log of economic value per hectare per year. The independent variables included wetland type, service type, country characteristics, and method used. This statistical model helps predict ecosystem service values for any new site that shares similar characteristics. This is the essence of meta-analysis benefit transfer, using a large evidence base to create a prediction equation rather than pulling a single number. The results were provisioning services like food or raw materials. The values ranged from 95 cents to $2,000 per hectare per year. And in the case of the regulated service like flood control and nutrient retention, the values ranged from 62 cents to $11,000 per hectare per year, an even higher variance. And this wide range shows the importance of context, wetland location, condition, and service type matter a lot. Now that we have seen how benefit transfer works and explored the case study, I'd like to introduce a key tool that makes this kind of analysis possible on a global scale: the Ecosystem Service Valuation Database, or simply ESVD. The ESVD is the world's large open access database of monetary values for ecosystem services. It's like a powerful resource for anyone working in conservation, environmental policy, or natural capital accounting. The ESVD is curated, peer-reviewed database that brings together over 7,000 valuation records for more than 1,000 studies covering 15 major ecosystem types. The ESVD was created to provide credible numbers to inform conservation and development decisions, make ecosystem evaluation more accessible and consistent, and help decision makers to understand the economic trade-offs of land use, policy change, or restoration projects. The ESVD supports many practical applications: benefit transfer, estimating values for ecosystems in new locations, cost-benefit analysis, comparing like conservation or restoration benefits with costs, natural capital accounting, integrating nature into national accounts, corporate risk and sustainability reporting, and identifying data gaps in global ecosystems valuation research. This is like an incredibly powerful tool, but it's important to be aware of its limitations as well. So geographic coverage is uneven. For example, some regions in Africa and Asia are underrepresented. The quality of valuation studies varies, so it's important to screen carefully. Some records are derived from benefit transfer themselves. Those are flagged and shouldn't be used for another transfer. Still, ESVD is the most comprehensive and standardized resource we have today for economic evaluation of ecosystem services. As mentioned earlier, benefit transfer is quick and inexpensive. We know that it is efficient and cost effective, but must be applied cautiously. Its accuracy depends heavily on the quality and relevance of original studies, careful adjustments for context, scale, and time, and transparent communication of uncertainty. So you must be aware of these limitations when applying benefit transfer approaches. So let's wrap up by reviewing the most important points about benefit transfer as a valuation approach. Benefit transfer is all about leveraging its existing studies to estimate the value of ecosystem services at a new site or scale. It is cost-effective and practical, but it comes with caveats that require thoughtful application. But here are the big takeaways. One, benefit transfer is much cheaper and faster than conducting new primary evaluation studies. This makes it highly valuable for screening policies, planning, and large-scale assessments. Two, accuracy is only as good as the match between study size and policy size. Ecological, socioeconomic, and cultural differences matter. Three, benefit transfer isn't one size fits all. We have seen unit value transfer, which is quick and simple, but then we have like the adjusted value transfer, the benefit function transfer, and the meta-analysis, which is like the most advanced and reliable when data rich. The ESVD makes it easier to apply benefit transfer systematically, transparently, reducing manual data collection time. Benefit transfer values are estimates. They should guide decisions, not replace context-specific research when precision is essential. Always communicate assumptions and confidence levels if possible. Benefit transfer helps scale up ecosystem valuation to national and global levels, supporting conservation finance initiatives. With that, I conclude today's lecture on benefit transfer. I hope it has been helpful. See you next time.